Hey everyone, I'm Garrett with Team Faceoff. I'm here to introduce you to our senior design project, a facial recognition system that unlocks a door. Now let me introduce you to our team. Jared Nixon, team lead. Garrett Eladui, myself, software integration. Jason Parker, hardware integration. Daniel Hasty, software support. All developed at the beautiful University of Alabama in Huntsville under the experienced and supportive professors like Dr. Wells. What you see behind me is what we made in my garage out of wood to simulate a door. The original engineering requirement that we were given by our sponsor is that we would use facial recognition to unlock a server rack door. So the way that it works is that we simply place our face in front of this camera right here and push this red button. That takes a picture with this camera. The image is then processed by the software on the Raspberry Pi. The image processing software then verifies if there's a face in the image or not. If there is a face, then the actuators will move in order to unlock the door, and the LED light will turn green to indicate access granted. If there's not a face in the image, then the light will turn red and the actuators won't move. Now, facial recognition really just comes down to detecting combinations of pixels in an image that are aligned in a particular pattern. If we remove color from an image, we are left with white pixels and black pixels, and then combinations of gray pixels that are different levels of darkness. So the software looks for sections of the image that have both dark pixels and light pixels. This allows us to detect edges. There are several main types of edges. We have the standard edge feature. An edge feature is simply where we have one set of lighter colored pixels and one set of darker colored pixels right next to each other. And then line features. A line feature is where we have a set of dark pixels in the middle and a set of light pixels on either side. So by simply detecting edges in a black and white image, we can tell the software what patterns of the edges a face should look like. For example, here at the top, we have a set of very light colored pixels right on top of a set of darker colored pixels. With this section of the image detected, we can then detect other edges in the image. Here we have a line image with one set of light pixels in the middle and dark pixels on either side. Now with the combination of this line feature here with an edge feature here, we know that the combination of these two features most likely makes up a set of eyes and nose. This is how we can tell that there's a face in the image. The software that we are using is an open source software called OpenCV, and the particular library that we are using is called HAR Cascade. Now the software uses a machine learning algorithm. This means that you can teach the software to look for certain patterns of pixels. So essentially, we give our software two sets of images. We have good images, which contain an object that we're trying to get our software to detect, in our case, a face. And then we have bad images, which don't contain a face. We tell the software that we only want to look for commonalities in the good images, which should give us all of the faces. After supplying these two sets of images, the software can look at these images over and over again until it begins to detect the pattern in the good images versus the bad images. The more and more this program runs, it gets better at detecting faces in an image. So essentially, we could use this concept to detect any kind of object in an image, as long as that object has a somewhat consistent pattern in all of the images. What OpenCV did for us is they already supplied these two sets. All we have to do is import an XML file that already has a lot of facial recognition data in it.